Alright, let's get started. Okay, so the ES10 is coming due tomorrow, or Saturday, particularly day. How's that going? Any questions, problems? I had a few visits to my office yesterday, 3 or 4 from students whose servers couldn't even get off the ground. And it just turned out that somehow in the process of taking PS9 and turning to PS10, some configuration had gotten messed up. So I sent out a note yesterday. You should have received explaining the most common things I had seen that could go wrong, just make nothing work at all. Okay. Well, the next assignment, PS11, will come out tomorrow, and it will be due a week from Monday. And it will involve creating what I call a string socket, which you can think of as a wrapper around a regular socket. It's a little easier to deal with. And then you'll use your string sockets in PS12 to, like I said, to implement a piece of a web server to use with your logger service. So it'll be some low-level thread-based, task-based programming on PS11. So my goal today is to get you ready for that, and we started last time by talking about the simple chat server. I want to revisit that, and I tried to think of some ways to help you see what's going on, because it's easy just to get dazed when you look at it. So I'll try that, and then I'll probably spend most of the time just talking about the assignment of string socket, explaining how it's supposed to work and how it's tested and all that. Okay, so up here we have the simple chat server. And as you recall, the way it works is a client connects. The server, when the connection occurs, the server sends back welcome. So welcome gets displayed in the client. And then after that, whatever complete lines are typed in the client and they're then sent to the server just capitalizes them and sends them right back. So it's just echoing what's typed to it. At the heart of the chat server is a socket, are sockets. So every client-server connection involves a socket on the server side, and the server can be connected to multiple clients. So there could be multiple sockets in use. It's just a number of sockets, just a way to send bytes back and forth over the network. In this case, between a client and a server. So here's the constructor for a simple chat server. You see I put a breakpoint on line 29 there. So that's where I create the TCP listener. What's the job of a TCP listener? Besides, it says listens for incoming connection requests, but besides what the comment says, what does this TCP listener do for us? Yeah?
Like set up a socket and then change to a different port and then go back into listening?
Right, so the job of a TCP listener is when it gets a request to communicate from a client, it sets up a socket connection between the client and the computer that the server is running on. So it'll pick a port, and to communicate with the client. So it's where the sockets come from. So we don't create the sockets directly, we get them from the TCP listener. So you can see the first thing it does is start the server. The constructor starts the server, and then it calls begin accept socket. So this is the asynchronous style of the sockets we're using and the TCP listener we're using. This just says start waiting for a socket connection request to come in, and when it does, call this method right here. And that method right there is defined in here. So the first parameter to begin accept socket is a delegate that is called when a socket connection has been established. We don't know when it will happen. It will certainly happen on a different thread, but at some point it will happen. Now, I've been waiting in vain for anyone to ask me what this second parameter is for. What's that second parameter? I'm glad you know. Okay, I call that the payload. I think the actual documentation calls it something different. Essentially, when connection requested is called, it's past this object. this object contains, among other things, that object. Okay, so whatever you put here will be available as a property of this object here when connection requested is called. So it's basically a way of passing information from here to down here. All right, for example, we could pass, let's say we passed 1 as the parameter there. Okay? And down here we did result dot, oh shoot, what is it? Oh, async state. So what would happen is, when this was finally called, it would print out 1, because that was the object we passed as a second parameter to the begin accept socket. So it's just a way of getting information from one group to another. On the other hand, if I come down here, and down here I'm going to recall begin accept socket. If I put 2, then when the next connection request comes in, this will print out 2. So you don't have to use them, and I didn't use the payload here, I just used null. But sometimes you can think of a need to pass information from one place to another, and that's how you do it. Okay. So let's test out the chat server. I've put breakpoints. Let me show you where I put breakpoints. I put breakpoints here at the constructor. The other place I put breakpoints are, I should have moved it. The beginning of connection requested. So that's going to be called automatically when a connection is established. At the beginning of message received, which is called automatically when there's some bytes that have been received and need to be dealt with. And also message sent, which is called automatically when bytes are sent out. Okay? So I put them in front of places that where things are going to happen automatically for us. So let's run this. I'm going to go dig it out. Okay, so they're at that breakpoint. So what we're going to do is, someone tell me which F key for stepping over.
10.
10? No, I guess it's function F10.
You.
Yeah, I might mess that up. Hope I didn't mess you up.
No, I'm good.
Okay, let's try function F10. Okay, so we start the server, we print out begin accept socket call, and then we're about to call begin accept socket. So I do that. This is too hard. I'm going to have to redock this so I can see my controls. Sorry about this. It's the wrong one. Stick it back there. Okay. So I'm down here now, and then I'm just going to say continue. Okay. So what's happened when I hit continue? Okay. So I hit continue. Where I'm executing now, what's happening? What's the server up to at the moment? Yeah.
It's just waiting for a client to connect.
Okay. So all that's happening is the TCP listener is off doing its thing, waiting for a client to connect. So none of the code that I've written here is executing at the moment. When that connection request does come through, though, then this method will be called. And I have a breakpoint set. So we can see that happen. If I, down here I have, no, that's the wrong one. I have a telnet window open. So if I say open localhost 4000, then watch what happens over here. I hit enter. Okay? And suddenly, I'm up and executing again. And what happened there was the connection request came in, and the TCP listener finally made the callback to this connection requested right here. Okay? So it's going to print out the value of the async state. I can put the mouse there and see that it's 1. So that's the payload that got passed through. I'm not doing anything with it other than printing. So what I'm going to do when I get a connection request is I have to call end accept socket. So these things come in pairs. The get accept socket I called up yonder to set things off. When the callback gets called, I've got to make a call to end accept socket to complete the synchronization with TCP listener. And what I get for my trouble is the socket back. So that's how I get the socket that was actually created for me. So now I've got the socket, and now I'm going to call begin accept socket again. And we've mentioned this several times, but why do we do that? Yeah?
Because it'll only do one accept like once, and then you have to call it again.
Right. A begin accept socket, it doesn't say begin accept sockets, it's socket. So as soon as it finds a socket, it calls a callback. It's done. It's not looking for any more connections. So we have to tell it again to start doing that. Okay? So it's looking for sockets. In the meantime, we're forging ahead. We create a client connection. So I'll step into that. Well, with there. Oh, I see. It's initializing some variables. Okay, so here we are in the client connection constructor, and all the client connection constructor does is set up the instance variables it's going to take back, it needs to do the sending and the receiving. So we print out that we connected, we remember the socket, we clear out the incoming strings, we clear out the outgoing strings, and then we send a message. We send the message, welcome, and then we call begin receive. And then we're done. And what's happening then, after we execute begin receive? In fact, I'll just hit continue. Right? How do we get here? So I hit continue, and somehow we ended up here. Well, let's go see what happened up here. This is the code that created the client connection. How did we end up in message sent? Yeah?
The message received is passed as a delegate to begin receiving. Is it callback?
Yes, but we did start begin receive, and that's going to call message received when we type a complete line on our client. But we didn't do that yet, and that's not where we ended up. We did not end up in message received.
Oh, yes.
We ended up in message sent. Yeah?
Send message, set up a message that it's going to send once the constructor finishes and it's able to send messages.
Right. So send message sends out the message welcome right then, actually. So we called send message while we were building the connection. So let's go find send message. Send bytes. Where is send message? Well, I'll just go find it with. Go to definition. Okay. So we called that method, and so I just stepped over the call. But it basically, we'll look at it in more detail later, it just sent the message out for us. So that message got sent while, on a separate thread while we were doing our thing. Okay? Now, though, if I do continue, we're sort of just hanging out. So what's going on now? How could I get some action to happen? Okay?
Gotta send a message from the client to the server.
Okay, I could make things happen by doing two things, actually. I could type into my client and send some bytes up to the client. I mean, from the client up to the server. So that would wake up that would call one callback, because our socket is waiting for bytes to arrive. What else could I do? Well, besides disconnecting would do something, but besides, I suppose I don't want to disconnect.
Sending a message?
Well, the messages, all I can do from the client, I can just type stuff and that goes up. So that's sending sending bytes to the server. Yeah?
Set up another client?
Right, I could open another telnet session and have two clients communicating with it at the same time. So in other words, I can come down here, open up a telnet, say open localhost 4000, and boom. The TCP listener saw their connection request come in, and it's called connection requested. And so suddenly my methods are back to life. But it has to open a connection. And if I continue, it's going to do its thing, which includes sending a message out. Welcome. And then things go quiet again until something happens. So let's call something else to happen. Let's go to the telnet client and type something. So if I type A, that is sent immediately. So the byte, it doesn't save up bytes and then send it. Telnet just sends bytes as soon as you type it. So my socket received bytes. So it calls message received. And what did I do to screw that up? I think I typed something by accident somewhere. Okay. So message received is called. We have to call end received. Remember, they come in pairs, and it will tell us how many bytes were received. So I'll step over that, and it tells me 1 byte. Okay, I typed the letter A, so that 1 byte came up. So bytes read isn't 0. What I got to do is convert the bytes into characters. So let's try that. So that does a decoding, and that tells me that my 1 byte turned into 1 character. And if I keep going and append those characters to mine, so now incoming is the string A. Okay, so I've appended the character to incoming, and then if I've got any complete lines, I want to capitalize them and send them back, but I've got no complete lines at this point. So this code right here is going to have no consequence. It's looking for new lines in the incoming, doesn't find any. And so what's it going to do? What's the last thing that'll happen? Yeah, it's right here. It says ask for more data. Once it's done processing the bytes that came in, it calls begin receive again and says, all right, tell me when more bytes come in. Okay, now, you might assume from what I just showed you that you can just assume that you get 1 byte at a time. Is that true? No. When might you receive more than 1 byte? Yeah?
Something pasted.
Right? Maybe I paste something into that telnet client, and that's all sent up at once. Or maybe I replace the telnet client with a client that's generating text at a fast and furious pace. And instead of sending bytes, it's sending megabytes. And typically the socket won't try to send, or the client won't try to send a megabyte at a time. There's limits, and so it'll probably arrive at 2K or 4K bytes at a time. So in general, you don't know how many bytes you're going to get. And you can't assume you'll get all the bytes at once. You can't assume you'll get 1 byte at a time. You just don't know. You just got to deal with what you get. But anyway, when you're done doing it, you've got to call begin receive again to restart things, because otherwise you won't learn about any new bytes. All right, now. Okay, so we're back in a quiescent state. Actually, let me say continue here. So things are quiet again. So let me go type a new line and see what happens. Okay. So I'm at message received again. I find out 2 bytes were read. Okay. Why 2 bytes? I think it's carriage return new line. So I actually sent those 2 characters. I read more than 0 bytes, so I keep going. I've got to convert into bytes, so I convert them into characters, and there are 2 characters. I append them to my string, and I start trying to split it up, trying to find a new line. And eventually I'll find a new line. And when I do find a new line, I will send it as a message. Okay, so let me put a breakpoint here. Continue. Okay, so I found the line A, carriage return new line. So I found that line, and so I'm going to call my method send message to do the sending. So I'm going to step into that. Okay, so here's send message. So what send message does is it has 1 or more lines that end with a new line that it wants to send. And the first thing it does is set a lock. And let's think about that lock. What's it for? Why do we need that lock? Let me back up. Before we talk about why we need that lock, why is it important to study this implementation? As opposed to, say, staring at your screens. Yeah?
Because we'll have an assignment about it.
Right. The structure of the string socket is really similar to the structure of this thing right here. Just like this thing right here, your string socket receives bytes. And it converts them into strings, just like this thing is doing. And instead of printing them out, it provides them back to whoever's using the string socket. And when it gets strings, it converts them to bytes and sends them over a socket. So the structure is very similar. So you can save me a lot of time by asking the questions now instead of next week. Yes?
I have a question. Since like this program is like receives or it's sending and receiving individual bytes, what happens?
Well, it's not sending and receiving individual bytes. It's sending and receiving chunks of bytes. In this case, sometimes individual.
So when a packet is lost, does this when you're using the sockets on such a low level, does the TCP listener, the ways that we're sending it, have some sort of
Yeah.
like way to account for that?
Right. So on the networking stack, what we're working at is a level above which, at a lower level, things like packets are dealt with, and missing packets are dealt with. So we view the socket as reliable. It's not going to have any missing information. That's being dealt with at a lower level. So when you study networking, you can work anywhere from the wire up to the web server. We're somewhere in the middle. Yeah.
There was a part where you had, like, you were reading in a new line character, and you had, like, single quotes around it, and I just was wondering if you could go back to that code. Thank you.
Okay. So this was
Yeah, that.
right there.
Yeah.
Let's just say if the ith character is a new line character, then we want to take those characters out, that's a complete line, and send it out as a message. Send it back to the client. So we're just looking at our collection of characters we've got and taking out complete lines and sending them out. Right? We're just looping through the characters, looking for new ones. Okay? So, back to the lock. Why do we have this lock? Why do we need exclusive access to the send mechanism? We only send 1 line at a time. Who else could be trying to send? What do you think? Yeah?
Another socket.
Okay. You can have more than one client, right? One more client connection. Each of them has its own socket. But is that really, do we really need to guard ourselves against some other socket trying to send stuff out? Well, every time you get a new connection, you're going to create a new client connection object. A client connection object has, look at all these instance variables it has. It has the socket it's dealing with, the incoming and outgoing arrays, a decoder, byte arrays, character arrays, this send is ongoing flag, this send sync object, pending bytes, pending index. It's got its own copy. So the truth is, each socket can, no socket has to interact with any other socket. One client connection has all the state it needs to communicate. So they don't interfere with each other at all. So it's completely parallel that way. Now, what if I made a simple change and made this object right here static? What impact would that have on my chat server?
Then we will only have one copy of the static variable.
Right. If we made it static, every client connection would share that same object. Which means they would all share the same, they'd all be trying to acquire locks on the same object. Which would mean that only one socket could be sending at a time. Which would be silly. There's no reason to prevent multiple sockets from simultaneously sending and receiving bytes. So if we made that static, suddenly our throughput would fall. And if we had clients that were really slamming the server with lots of data, they couldn't run in parallel anymore. They'd have to take turns. So that's why that's not static. But given that any given client object any client connection object is only dealing with a single socket, why do we need to lock it off? So back to my original question here. Right here, when we're sending a message, why do we have to acquire exclusive access to the instance variables of the client connection? Yeah?
Maybe if it's being spammed, like hundreds of times a second.
Well, spammed 100 times a second, but when you set a lock, you're trying to prevent some other thread from interfering with what you're doing. But what other thread? Yeah?
You could be receiving messages at the same time, and that might be affecting what you're sending back.
Okay, so let's go back to the spammed idea. Say the client is just sending a whole bunch of stuff, and the socket is telling you, got something, got something, got something. Every time it calls begin receive, it's on a separate thread. So you might worry that this gets called multiple times. Actually, that won't happen, though, because what? Why does begin receives only happen one at a time? Why can't they happen in parallel? Yeah?
Because that only happens one at the same time.
Well, and more importantly, when the message received is called, we deal with it completely before we call begin receive again. So it can't receive any more bytes until we tell it to start looking. So we still don't know what's the other thread we have to worry about here. I don't know if you've been following, but right there in the middle it identifies the thread we're on. So we're on thread 16172 right now. And if you watch over time, you'll see different numbers up there. So this is a very multi-threaded kind of program. Yeah?
Does that have to do with that incoming string that contains all the stuff that's been sent to it before it gets sent back out? Or if you're modifying that?
No, it's not. It's not with the incoming string either. Okay? Let me show you. This method right here, send message, is called when the client connection object decides it needs to send a message out. So it calls that. And that happens when begin receive is called. Okay? This method down here, message sent, is called when. So when an attempt is made to send a message out, like we just did in that other thread, this method will be called when the message has been sent. Okay? So on the one hand, we got the client connection object calling send message every time bytes arrive, with a new line in it. On the other hand, we get this method called when an old message has been successfully sent. But the problem is we can ask to send 1,000 bytes. It may be only 500 are successful. So the other thread is the send side of the socket. we have two methods here that are competing to use the socket, competing to access shared data. So let's step through that, because you'll see this exact same thing manifest in your string socket. Okay, so we require exclusive access here. We append the outgoing lines, and then we look to see, are we currently trying to send bytes out the other end? Okay? Well, we're not, because this is the first message we've sent. So that will, there's not a send ongoing. So we set send ongoing to true, and we call send bytes. And I'll step into that. Right? Send bytes, it makes sure that there's something to send. Make sure there's some bytes to send, and sends them. So it's going to send the bytes by calling begin send. It's going to set up an array of bytes called begin send, and when begin send is done, message send will be called. So let's do that. Okay, so the bytes were sent. Message send is going to find out how many bytes really were sent, and if they weren't all sent, it's going to try again. So on the one hand, we got this method, that's the callback method. If all the bytes were sent, it tries again. If all the bytes were sent, it tries again. On the other side, we've got send message, which is trying to send bytes, trying to send bytes. They could both simultaneously be banging on the send mechanism. So that's what the locking is for, is to synchronize those two, so that we don't have both threads modifying the same arrays and stuff at the same time. Notice that my working thread changed, I think. Because I'm on a different callback now. So that's what the lock is for. And you'll see the same pattern in your string socket. In fact, you should start with your string socket. Start with this code as a template. You're going to get to the point where, I mean, you've got to, well, I'll just leave it at that. So there's a lot to digest here as to how this is all working. It's operating on a socket just like your string socket will be. All right? There's only so much I can do up here. It's better if you sort of step through it yourself. And if you want to step through it yourself, I recommend you do what I did and stick breakpoints in front of the callback methods. And otherwise just step through it and see what's happening. But you need to understand how this works before you understand it. Before you can attack the string socket, which is coming up fast. Okay? Try again to encourage some questions. I know it's tempting just to say, I'll figure it out next week. That's better than I'll figure it out a week from Monday, but it's better to figure it out today. Yeah?
So you have a lot of console.write lines.
Yeah.
And a lot of the text looks the same. So like, how is it actually helping you?
Yeah,
what's
so,
going on when it,
so I was experimenting before class with how to help you see what's happening as this thing runs.
yeah.
And so I put all these print lines in, and then I ran it, and there was so much text coming out. There was no help whatsoever. So yeah, it was a failed experiment. You're very perceptive.
If we were trying to do some write lines like that, what would you just recommend that we not do it like that?
Yeah, the problem with debug, I wouldn't do it to debug. I was doing it to trace.
Okay.
But the problem with that stuff is, it's just, if you're outputting too much,
It's not useful.
it's not useful. Unless you're putting it to a log and studying the log later.
Right.
I experimented with putting a breakpoint on every method, and even that was bad. I finally decided the right place for the breakpoints was on the main and all the callback methods, because those are the ones that are launched without your control. It's tough. And if you do it, just pay attention to that worker thread up there, and you'll see. You may see the same number come up more than once, because what Visual Studio is using is what's called a pool of threads. It has some threads, and it might have 10 threads pre-created, and it reuses them over time whenever it needs a thread. Yeah?
So does each socket object have its own copy of the send-sync object you're using in the lock?
Not each socket object, each client connection object
Okay.
has its own send-sync, because it's not a static variable. Right? So synchronization has to happen when you're sending from a socket. The synchronization is not necessary between sockets. Two sockets are completely independent. Okay? All right, let's take a break and then we'll actually look at string sockets. All right, let's get started again. Okay, so this isn't pushed yet, but this is going to be branch 11, PS11 branch that you'll be working on. And I'm going to talk through what I'm giving you over here. So I'm giving you two solution items. I'm giving you a DLL called SS, and I'm giving you an XML file called SS. That just contains the IntelliSense data. SS is a working implementation of string sockets, except it's called SS instead of string socket. And the reason it's in there is for testing, and I'll explain why later. So, well, I'll explain why now. You're going to have a testing problem. How do you suppose you test a string socket? Yeah? You need, right, to test a string socket, you need part of your code has to pretend to be a client, the other part has to pretend to be a server, and you've got to talk back and forth between the client and server. So that means you need two string sockets. One string socket's on the client side, one's on the server side, all inside the same test case. So suppose you want to test whether your string socket implementation receives correctly. Okay? Then this string sockets have to do some sending, right? It's going to have to send stuff, and then your test cases will see if the right stuff arrives on the other side. Suppose it doesn't. Suppose that you fail the test. What does that mean? Is your receive code wrong? Maybe your send code is wrong. So the test cases, what you want to do is one side use a trusted string socket implementation, namely ISS, so that you at least know that the stuff is being reliably sent. And then you can just worry about whether it's being received. So it makes debugging and testing a lot easier if you can trust one side or the other. So I can do that. Notice the first project is called Grading Tester. So it contains the grading tests. So that's another advantage you have going in. You've got test cases, and furthermore, they're the very test cases I use for grading. All right, so that helps. And then finally, you got the string socket class. String socket client, string socket listener are meant to replace. This is meant to be like a TCP listener, except it gives back sockets instead of string sockets instead of sockets. This is meant to be a TCP client, which would be the heart of the client. That's meant to also work with string sockets. They're already implemented. That just leaves stringsocket.cs. That's what you got to create, and it's already stubbed out and has some code provided, so you got to fill in the blanks. Okay? Yeah.
Don't mean to look a gift horse in the mouth, but
Yeah.
you're giving us a grading suite.
Yep.
We haven't even created tests or anything. Is that because this is going to be that hard that we need the test to even be able to do it, or?
Well, in the past, I have done my usual thing and said create some test cases and so forth. And what I find is that students create really bad test cases and they fail a lot of mine. Okay? And the problem is because what's it take to write a test case for a string socket? Yeah?
You actually have to know how the string socket works.
You've got to know how it works, but there's something else that's true of any project. What's unusual about a string socket, or what's characteristic of a string socket? It's multi-threaded. It's a very multi-threaded asynchronous thing, and so your test cases have to be multi-threaded. I'll show you what I mean. We'll go through the test cases as well. So it's just, this is really your first experience with really writing multi-threaded code in a serious way. And I think it's enough of a problem to implement string sockets without having to worry about getting multi-threaded tests to work as well. Yeah?
So that ss.dll is what contains your version of
Yes.
string socket? Okay.
Right. So, so if you want to create one of your string sockets, you say new string socket. If you want to create one of mine, you say new SS. Okay? So yeah, another thing that makes this assignment is, students have often struggled in this assignment, but I haven't told you the biggest factor yet why students struggle with it. What do you think? Yeah?
They start late.
Well, that's true of every assignment. That's good, but it has to do with timing. All right, no guesses. Because it's just so late in the semester. It's, the next to last week of the semester is when this is due. And, everyone's tired coming down the final stretch, and all the classes are hitting home. And it's just, there's only so much I can ask you to do. So I'm just trying to make it as easy as I can. Okay? And I don't think it'll be hard if you understand the whys and wherefores of the simple chat server that I showed you, and sort of use that as a model of how you do things. Okay. Another thing I'll say is a proper string socket design would say something about what to do when exceptions occur. And I used to have a version of this assignment where that was complicated by specifications of how to deal with, say, an exception occurred on the underlying socket. How do you report it to the user of the string socket? And in the end, I just stripped all that out. So that's another way I'm trying to simplify it, is won't worry about exceptions. If they happen, then things crash. It's not a very robust string socket. But it's robust enough that we can pass the test. Okay, so let's look at the actually what you'll be doing, the string socket class. First thing, you see two delegates up there. Send callback and receive callback. So that should be a clue that the asynchronous nature of sockets are reflected in string sockets. So just as in sockets, when you want to send a string, everything works at the level of strings though, not of bytes. So if you want to send a string out, you call a method, begin send, and when that send is completed, when you call begin send, you give it a send callback. And when it is completed, your send callback is called. So the callback that you give when you send something has to be of that form. And the callback that you give when you're doing receiving needs to be of that form. So that's just the definition of the two callbacks you'll be using for sending and receiving. Okay. Okay. So a string socket obviously needs to contain inside it a socket. So every string socket object, if you cut it open, there's a socket inside. So it's just, the job of the string socket is just to make it easier to use the socket. Now to create a string socket, you'll first have to create a socket and then pass it to the string socket constructor. That's dangerous because, let's say you're over here using the string socket through its methods. Well, you could also take the socket and make raw socket calls on it. And what would happen if you did that? You're sort of using the socket on the side while you're also using the string socket that's wrapped around that socket. What do you think? Yeah, it's going to screw things up. Some of the bytes that come in, you're reading over here by calling begin receive on the socket, and others you're dealing with over here by calling the string socket. It's going to get screwed up. So you just have to be on your honor that once you wrap a socket into a string socket, you stop using the socket methods. You just access it as a string socket. Okay? So the constructor is going to build a socket. Remember the socket, remember the encoding, and do some other stuff. So you got to put code there. What do you think the constructor will do? What will it need to do besides remembering what socket it's playing with and remembering the encoding? At a minimum, what will it have to do? What do you got to do to a regular socket before you can get it to do anything for you? Yeah?
Put in the IP addresses of both.
Well, that's already done to create the socket. That's already been done. Yeah?
Sending callbacks, or socket callback methods.
Yeah, you're going to have to call begin receive to tell it to start listening for incoming strings. So, you got to turn things on. Okay, shutdown is implemented for you, close. A shutdown method tells the socket that it's about to be shut down and gives it, it gives it some time to finish, and then close actually closes the socket. You don't have to do anything there. Yeah.
I was just curious about the iDisposable interface at the top of this. What was that for?
Now I don't remember. iDisposable. Provides a mechanism for releasing unmanaged resources.
You could just close this automatically when you're in the using statement.
Yeah, so maybe that's the interface that you have to implement to be usable in a using statement. Thank you. Okay. Then we got begin send. Now, begin send, you pass it a string to send. So that's a string you want to send out to out of the string socket. You give it the callback to call when the send is completed. So in this case, I don't want to be called when part of the string has been sent. I want to know when the entire string has been sent. And then we got the payload object also passed back. What is begin send going to have to do? Someone calls begin send. How will you implement that? What will the code look like? Yeah.
Convert the string into an array of bytes and begin sending.
Okay, you got to convert the string into an array of bytes. You've got to remember the callback. You've got to store the callback somewhere. You want to store the payload somewhere. You've got to convert the string into bytes. And you've got to send the bytes out. Well, how do you send the bytes out? your socket. The socket that you have inside, you have to use it to send the bytes out. It may be that you do that, and before all those bytes have been sent, begin send has been called 100 times. You may be in a situation where you have 100 callbacks waiting to be called, and 100 payloads. And when the first string is successfully sent, then you call the first callback. When the second string is sent, you call the second callback, and so on. So you've got to have state in here to deal with the fact that the sending may not happen as fast as you'd like. You can get, it's possible you could get lots of calls before any bytes have been sent. So your state has to be kind of robust that way. And you have to know when a complete string, at what point a particular string has been completely sent as bytes. So at that point you can quit call the callback. And then you proceed with the rest. But what does a chat server do when you ask it to send a string? Yeah?
It capitalizes it first?
Well, it capitalizes it, sure, but then what happens? How does it send it? Yeah?
Calls send bytes.
Yeah, it calls send bytes, and send bytes converts the string into bytes and starts using the socket send mechanism to send. And if it finds out it didn't send all the bytes, it tries again, and it keeps doing it until it finishes. So that mechanism is already built into a simple chat server. Taking a string and sending it completely before sending another string. So you can leverage that idea. Same idea here. Okay? This method is supposed to be thread safe, which means we can have multiple threads sharing access to a string socket, simultaneously calling begin send on separate threads. That's just a way of saying you've got to provide your own synchronization with locks or whatever. Okay? So that's begin send. And this callback is called with the payload. Then you've got one called begin receive. So when someone calls begin receive, you give it the callback, the payload, and this is an optional parameter. So assume this parameter isn't here for the time being. Okay? What we're asking is, okay, begin receive. As soon as you've received a complete line of text, terminate with new line, call the callback and pass the string back to wherever it came from, wherever the request came from. Okay? What's your chat server already doing? How does a chat server deal with incoming bytes? Yeah?
String builder?
Yeah, it basically uses a string builder to accumulate bytes. It converts the bytes into characters, accumulates the characters until it's got a complete line. Now what the chat server does, once it gets a complete line, is it sends it back to the user. When you get a complete line, you'll call the callback. But just as with begin send, begin receive is going to have to, it may get multiple calls, so it may have to be accumulating a list of callbacks and payloads. It needs to serve in the order in which it received them. So it may have a bunch of pending callbacks it needs to make sometime in the future when enough data arrives to use them. So you need to implement begin receive. And the rest, and that's just dispose is implemented for you there. So essentially, you've got to implement begin receive, begin send, and the constructor. So you've got to declare instance variables. Constructor will initialize them, and then begin receive and begin send are dealing with sending and receiving streams at the level of bytes. Right? It'll be doing socket calls. So you're going to have to become a user of sockets as you implement string sockets. Yeah?
So we don't have an equivalent of bytes sent to check that it was all sent?
No, because the rule in the string socket is I ask you to send this string, and you don't call the callback until the string is definitely sent.
Okay.
If you're sending the string, so if begin send is sending a string and only half the bytes get sent, I want it to keep trying until they're all sent, then call the callback. So I'm trying to make things easier on the user of the string socket. Okay? Now, ultimately, who will be the user of the string socket? You. All right. String sockets will be at the heart of your of the final assignment, which is to make a very stripped down web server. So you, at the heart of it, you will have a string socket instead of a plain socket, so you can deal with strings and characters instead of arrays and bytes. And as part of my program of trying to make things easier here at the end of the semester, you will have your option on PS12 of either using your string socket implementation or mine. Okay, so if you can't get your string socket to work, that's fine. I'll be giving you the DLL for one, so you can just use mine instead. Or if you want the feeling of having a completely, a web server you've completely implemented yourself, then you want to use your version. Now, one other thing that I skipped over, I realized, was that optional parameter right here. So when the optional parameter is present, your job is not to read a complete line. It's to read that many characters and then return that string. So you can use this method to either ask for a complete line or to ask for 57 characters. I think it's characters and not bytes anyway. And that's there just because to deal with the ACT protocol, sometimes you know how many more characters you're expecting, and so you need to read exactly that many characters. Okay. So I'm about to go look at the test, which will reveal a couple things. And one of them is you'll get to see a use case for the string socket. But I'll see if there are any other questions I can answer about this. Yeah?
Could you repeat what you meant by thread safe again?
Okay. So when you create, let's say you want to put a linked list class into C#. So you could say, okay, I'm going to make a thread safe class, a thread safe linked list. And if a class is thread safe, that means that an object, a linked list object, can be shared across multiple threads, accessed simultaneously from those threads, and everything will work right. So that means that the implementation of the linked list class has to be full of locks and synchronization primitives to make things work. Okay? More common is you don't worry about that. You just create a linked list class, and you tell the user, if you need to use it across multiple threads, you're in charge of synchronizing the calls to it. So it just comes down to who does the locks. So in the case of the string socket, all the synchronization will be done in the string socket. You won't have to worry about it when you use it in your web server. Now, why do you think it's more common to have a non-thread safe class built into the library and require the user to do any needed synchronization? Why is that a more common kind of design? Yeah?
Because if you don't actually need, multi-threaded techniques, then it slows it down.
Right. The most common thing is it's not used across multiple threads. It's only used on one thread, and you don't want to have to pay the overhead of the locks if you don't have to. So you can put as much locking in as you need. Yeah?
You could also have probably multiple different non-thread safe classes, and you only need one lock to synchronize all of them.
Yeah, and so that's just another way. Essentially, you as the application builder are in a better position to decide what kind of synchronization you need. The implementer of the class is going to have to always assume the worst case. And it'll slow it down for everybody, even if you're not using threads at all. Right, any other questions before I look at the test cases? Okay. So, test case. Okay, this is grading tester. Let's see what we got. Okay, so up here is some boilerplate code to create and open sockets and shut them down, so I won't go over that. Here's an actual test. So all my tests, it turns out I need some state for my tests. And so my tests are actually, what I have is a class that contains a run method. And That's the class. My test case is just a method that creates a test1 class and calls the run method and passes in the port to use. So every test case uses a different port. That's just so I can have some instance variables to go along with my assertions. And so you'll see that happening all the time in here. So let's look at what it takes. Look inside the try block, because that's the actual code that does the testing. Let me lower it so I can touch it. Okay, so let's see what's happening here. We are, so sender is an SS, and receiver is a string socket. So an SS is one of my string sockets, remember. So I'm taking one of my string sockets, calling begin receive on it, or begin send on it, giving it the string, and I want to find out, does that string make it to the receiving side? So I previously created the two sockets up there. Open sockets is doing that for me. How do I test to make sure that something got to the other socket? Yeah?
If an exception wasn't thrown?
Well, remember, you can't do that because maybe your string socket class has no code in it at all. It's doing nothing. So it would pass the test. We need to make sure that the right line, that the string hello made it to the other end of the line. So let's see what happens. We say begin send hello, call this callback when you're done. Okay? Now what does that callback do? Nothing. It's just there because we got to put one in there. So forget about that. Down here, and so then what is this code right here doing? We're telling your socket to begin receive and to call this callback when it's done. Well, what will that callback do when it's done? Ignore this part right here for now. So we begin send, begin receive. Yeah?
Set your line to whatever string it receives.
Yeah, so whatever string it receives, remember what it passes into this delegate is the string that's received and the payload. We don't care about the payload right here. So whatever it gets on the other side, whatever comes out of your string socket, it's going to store the line variable, which is this up here. And then we assert that hello and line are the same. So that's how we make sure that what we put in to the sending side came out on the receiving side. What could go wrong? Ignore this here as well. What could go wrong in the absence of this? Call begin send, begin receive to do the assertion. Yeah?
So receive hasn't actually received anything before it's
Right.
built?
This is all multi-threaded, remember? So it may be that you call begin send, you call begin receive, and nothing has happened yet. The sockets haven't gotten around to sending or receiving anything yet, and you immediately do this assertion and it fails because line is empty. So somehow we've got to do some synchronization. We've got to wait until we know that the receiver is finished with, the receiver has produced a string before we do the assertion. And that's what this thing right here, it's called a manual reset event, is for. So the way a manual reset event works is, you create one. Wait one is sitting on, blocks the thread. This blocks the thread until set is called on this thing. And when will set be called on this object? Yeah?
On when something is received.
When the receive callback is called. So this will be set on one thread. It'll be noticed it's been set on this thread, and it'll unblock the thread and do the assertion. So it refuses to let the assertion happen until. So that's just another synchronization primitive that C# provides. You'll see a variety of these here. Now, what if your begin receive implementation is so faulty that it never calls the callback? What will happen to this poor test case? It'll block forever. Test case will never finish because this MRE dot set was never called. And then what will happen is someone will post to Piazza, your test case is faulty because it blocks and never unblocks. Well, it doesn't unblock because the callback wasn't called. This is an example of a thread safe object. It's safe to simultaneously be setting it on one thread while you're waiting for it on the other thread. All right? So it's a simple synchronization idea. Right? So that's about the simplest test you can imagine on a string socket. You send a string and you make sure the string gets to the other side. Yeah?
Would it be possible to give a timeout on that manual reset?
That's a good question. What you'd want to do, if there's a way to do a timeout, which I don't remember, would be if it times out, return false. Or fail the test, rather. Okay. Now here's test 2. My tests always come in pairs. So test 2 is just like test 1, except we switch the roles. Now, the sender is your string socket, the receiver is mine. So before we were testing whether your string socket received lines. Now we're testing whether your string sockets can send lines. So we're testing the two sides. The two sides of the string socket are completely independent. So they can be tested separately. And like I said, if instead we just turn this into a string socket, then we're simultaneously testing both send and receive on your sockets, your string sockets. And that makes, if the test fails, you don't know why. Was it the sending problem or receiving problem? So the odd number tests are, and the even number tests are sort of jewels of each other. Okay? This is like test 1, because we're testing whether the payload was passed through. So, let's see what happens. We begin send hello, and we don't care about that stuff. Then on the other side, we begin receiving. And remember, this delegate is called when a line has been received, and it's supposed to pass through the line that was received and the payload object. And all we're doing is recording the payload object in this instance variable. Then we set that thing. This will unblock, and we assert that the right payload got through. Well, that's just testing payload. And then test 4 just reverses the roles of the two string sockets. So if this was all there were, you wouldn't have a very hard time implementing string sockets, or at least passing these tests. Okay? Let's look at what test 5 does. It is the same as the other tests, except it doesn't send the string all at once. It sends the one character at a time. So you can look what's happening here. Instead of sending hello in one fell swoop, it sends H and then E and then L and then L and then O and then U on it. And so that's testing that when you're receiving code, that you're actually accumulating the bytes that come in into a complete string that's terminated by new line before you make your callback. So we make sure that the right thing has come through. Okay? And then test 6, the roles are reversed. Okay? Test 7, rather than send hello, I'm sending a very long line. So what line am I sending here? What am I building?
Long list of digits.
Long list of digits. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2, 1. So it's going to be millions of characters long. Is that right? Yeah. Millions. Let's say a million characters. It's sending a very huge line. And the thing is that the underlying socket is not going to send the million bytes all in one chunk. It's going to send them in chunks of 4K or something. So it's guaranteed to arrive over multiple calls. So just testing the same structure to make sure the line gets through the other side. Then when we're testing, this is testing receiving, so we've got to make sure that you reassemble the things as they come in. When we test the other side, we test your sending, we've got to make sure that, if you create an array to hold all those bytes and try to send it, it's not all going to get sent. It'll only send some of them, and you'll have to, just like the chat server does, realize they weren't all sent and try to send the rest, and call the callback at the right time. So as the tests go on, data gets bigger. Okay? This test sends multiple lines. So let's see what we do. We have an array called lines. I don't know where that is. Oh, okay, I see what's going on. So just for the fun of it, I call begin receive first. So let's say limit is 1,000. I'm going to make 1,000 calls to begin receive. Okay? Before I've sent anything at all. Then I'm going to send 1,000 lines out. And each one will be a line that just contains a digit, an integer. All right? Is that a problem? Should I do the sends first? There's no rule. Right? Normally the two sides are completely independent. And in fact, in the chat server, it's common that begin receive is called before anything is sent from the client. So that's not unusual. As I receive lines, remember each line consists of a digit, 0 up to 999. So when we receive a line, this will be called, it'll take the payload that's being passed through is, what is the payload? Okay, I'm standing too close to it. Oh, okay, here's begin receive, here's the delegate, here's the payload I. It's just too insignificant to see. So this is going to be called, we pass the payload to an int and use that as an index of the lines array. We store the string that we got. So as we receive lines, we store them, we're told here's line 1, we store it at index 1. Line 3 goes at index 3. So make sure you get all those lines. Each time through, we increment count. Now, why are we doing incrementing in that common way? Call them interlock.increment of count. What do you suppose that accomplishes? Yeah? Right, count is being shared across threads. Notice count is being looked at here in the test case. So that method right there, increment, is a thread-safe way to add 1 to an integer that's being shared across threads. I chose to do it that way. I'm just trying to show you that there are lots of options built into the language for multi-threading. So that's just a thread-safe way to add it. So what happens is we do the 1,000 begin receives, then we do the 1,000 begin sends, and then we sit here and wait until count equals limit, meaning this thing has been called 1,000 times. At that point, we come down here and make sure that the right lines are received. What's happening here? This is yet another synchronization. What does spin wait sound like? Spin until. How would you visualize that? Yeah?
Like a loop, keep going.
Yeah. So a spin wait is essentially a busy loop. It's just a loop that runs and runs and runs and runs until something becomes true. Okay? Kind of a sort of a last resort you'd want to do to block a thread. So we sit here and we pass it the delegate to use, this one here. So it just keeps testing. You see this count equal limit, this count equal limit, this count equal limit. There may be a built-in delay, I'm not sure, between tests. And finally, when count equals limit, we fall out of it and we do the test. On the other hand, if 5,000 milliseconds pass and we're still spinning, then the spin stops and we fail the test. So it waits up to 5 seconds for everything to be received. If it doesn't happen, we fail. So that's 2 more examples of primitives, that and that. It's primitives for multi-threading. Now, what if we had chosen not to use interlock.increment up there? What would we have to do to add something to count? We would need to use locks. We'd have to synchronize access to count. And it kind of complicate things. So that's that. This one just tests the other side like before. This is just like the previous one, except every call to begin receive is made on a separate thread. So we loop 1,000 times. Each time through, we queue some work to be done on threads. And so rather than these begin receives being called sequentially, one after the other from the same thread, they're called potentially simultaneously from a bunch of threads, making sure you're doing synchronization right. Otherwise, it's the same idea. Same deal down here with the roles reversed. Here, it's the same idea, except we do begin receive, then some begin sends, then some more begin receives, then some more begin sends. So we interleave them. Roles are reversed. And I think this is the last one. And let's see what it does. Okay. So it does this begin send, and then it loops, and it calls begin receive. What does the callback to begin receive do? Just like before, to this one, and what happens? An infinite loop. The callback never returns. So, what does that imply? We're still making sure that all the callbacks got called. Right? Every time a callback is called, it's going to do that decrement before it starts the infinite loop. What does that imply about your implementation? What are you going to have to do to pass this test? If it's possible, you can call a callback and it may not work. Yeah?
Make sure you start receiving again before you call the callback.
No, because we want all the callbacks to be called. We want it to be possible to call 1,000 callbacks, none of which ever return. How can you keep an uncooperative callback from gumming up the works? It may not return, it may take a very long time, but either way. Right? So you're see what we're talking about, receiving here. You receive a line of text, you call the callback, it doesn't return. If you're not careful, your string socket never works again. It's blocked. How can you prevent the string socket itself from being blocked? Well, there's no provision for a timeout in the specification. Let's say you're writing a GUI and you want to call a method that's going to run for a very long time when the button is clicked, and you don't want the GUI interface to become unresponsive. What do? You call that. You make the call that the button wants to make on a separate thread. So this test case implies that when you make the callbacks from your string sockets, you'd better do it on a separate thread, so that even if that thread blocks, your string socket will keep functioning. When you do that, you want to find where, I forget where I did it, you want to use a worker thread. I'm kind of lost. One of these has an example of using a thread pool to get threads from. Okay? So, there you have it. Yeah?
Is the payload equivalent to like the JSON objects we're sending in with the rest? Is that?
Well, I use the same word for them. Okay. I mean, with the JSON objects, the payload is just another parameter from here to there. The payload is passed indirectly. We give the payload to the string socket or the socket, and then at some time in the future, it calls a callback and sends that payload along. Okay. So it's a way of communicating from the point where begin receive was called and the point where the callback, the method that was in the callback, the callback is made. So that's a little bit different. Okay? Okay, so this time next week, we'll be in the thick of it with string sockets. So.